Alrighty, good morning biology students. Today's lesson we're going to be focusing on experimentation as well as accuracy and precision. Some of these notes are going to be repeats of chemistry from last year, so if you had me last year, this shouldn't be new information for you. It should again be repeated from last year, so hopefully it's not too crazy and new. Today's learning target is that you can identify the variables in an experiment or an experiment done by another person, and this includes the dependent, independent, and the control. You should have already done your warm-up for today, so make sure you complete that. If you have not already, I believe it's warm-up number, I don't know the number because I don't know, so I'm sorry. Make sure you do that on Canvas, and then you will have homework today. Not that all homework isn't homework online, kids, so sorry. So, a model. You will need your note packet. A model is anything that's used to represent a system or part of a system to better understand the whole unit. So a model can be a lot of different things. A model could be an actual model like the one pictured here with atoms and molecules. A model can be a paragraph, a description modeling how something works. A model can be a diorama of something. A model can be a drawn picture of something. However, a model cannot be the thing itself. So I can't use a model of sugar to be sugar itself because it's the material itself. My water bottle cannot be a model for a water bottle because it is a water bottle. If I made a paper mache version of my water bottle, then it would be a model. So, accuracy and precision. Accuracy is how close you are to the correct value. So, what is the correct value and are you close to it? If so, you're accurate. Whereas precision is how close all your measurements are to each other. So, are your measurements close to one another, yes or no? And if they are, it is precise. And if they're really far apart, it's not precise. Oops, thought I had another note in there, but I don't. So, on your notes, I want you to draw circles of what you think accuracy and precision might look like in application. So, take a moment to do that. Pretend you're throwing darts at a dartboard. Where on that dartboard are your darts going to land? Where do you want them to go? You, of course, want to get a bullseye, so draw 3 darts of something that might be accurate, and then draw 3 darts of something that would be precise, but not accurate. So take a moment to do that. Go ahead and pause the video, and then when you're done, resume. I'm assuming you paused your video. So, welcome back. As you can see here in that first diorama, 3 little bullseyes just came up, 3 little bullseyes right here. So those are very close together. So this is an accurate and precise demonstration of throwing darts because they're all in the bullseye, which is what we want, and they're precise because they're really close together. These 3 darts aren't all on the bullseye, but they're pretty dang close to the bullseye, but they're not all bunched up together. So this would demonstrate something that's accurate. You're pretty dang close to what you want, but it's not precise because your answers aren't all bunched up together. These 3 darts hit down here. Not ideal for where you want on a dartboard, but they're really precise. But they, however, are not accurate. And then lastly, this is how I throw my darts. All over the place. So these are neither accurate nor precise. So, a controlled experiment. You have various terms that you will need to know for experimentation. I don't think we went over these last year. So the first one you're going to know is a controlled experiment. A controlled experiment is just an experiment that tests the effects of a single variable. And a variable is anything that you can change. So just like in math and chemistry, we're going to be using variables in biology as well. So a controlled experiment is just an experiment that tests the effects of a single variable. And there's different variables in a controlled experiment. Oh, I was way on top of things. A variable, like I just said, is any condition or factor that can be changed in an experiment. So the types of variables. We have the dependent variable, and that is what is being measured. Okay, and that's going to be recorded on the y-axis. And then we have the independent variable. That's the variable being tested. It's what you're changing. and it's on the x-axis. So the dependent variable depends on the independent variable. You're changing the independent and measuring the dependent. So our dependent goes on the y, independent goes on the x. Our control is what the independent variable is being tested against. So the control is what is normal, and we're going to go over some examples of that to better understand that. And lastly, the constant. The constant or the controlled variables are variables that are held the same in the experiment. So those are what are held the same because we're not testing those things. So let's do an example. Max conducts an experiment measuring plant growth. He finds that after 2 weeks, a plant that got water grew 4 centimeters, but a plant that got soda died. So take a moment, actually we'll do this first one together. What question is Max testing? So it looks like he's testing, will soda affect plant growth? Yeah, will plants grow if given soda? That's his experiment, that's his test. So what's the independent variable? What is he changing? He's changing that plants are getting pop. What plants are getting pop? And what is the dependent variable? What is he measuring? He's measuring their growth. The control, what is normal, would be giving the plants water. So the control is what is normal. We cannot test pop versus Mountain Dew versus Dr. Pepper because maybe they're both going to die. We need to include water in there to make sure the plants themselves are still going to grow in the environment, and it's actually the liquid that's changing the results. And then a constant, what do we need to hold steady? We need to hold steady a lot of things. The 2-week measurement period, the same type of plant, the same amount of liquid, the same amount of sun, the same type of soil, a lot of things. So here's another one. I want you to do this one independently. What is the effect of different temperatures on the number of chirps a cricket has? So take a moment and identify the independent variable, the dependent variable, and the control or constant variable. So what is the effect of different temperatures on the number of chirps a cricket has? So the independent variable, what we're testing, is the temperature. What different temperatures affect the cricket? And we're measuring the number of chirps. And then the control, what we're holding the same, is going to be the time frame, the time of day, the location, and the type of cricket. Or the constant, sorry. The control in this example would just be a normal day, like maybe a 50-degree day, depending on what you say is a normal temperature. One more practice I want you to do. How does heart rate change after running a mile, doing sit-ups, and playing basketball? Identify your independent, your dependent, and your constants. Pause the video here, please. Okay, so what are we measuring? We're changing the type of exercise, what are we changing? We're changing the type of exercise. We're changing the sit-ups, the running, and the basketball. We're measuring our heart rate. And our constants are going to be the person who's doing the exercise, how old they are, how long they're doing each exercise, and also what their heart rate was before they started. Here's another example that was done in Mythbusters. I'm going to go ahead and pause the video here. I'm going to have you watch this video on your own and then continue on into our next note video. Thanks.